Hey everyone, welcome back to Sidewalk STEM. I'm Dr. B here at the East Lansing Public Library, and I thought this week would be a lot of fun to look at a really cool demonstration that kind of looks at frost and ice and melting, which for all of you mid-Michigander viewers is kind of very timely right now as we move into the winter season. So to do this, we just need a couple of things. I've got just two metal cans here. These were formerly soup cans in a past life, all cleaned out. So we're going to use these for two comparisons. We're going to add some ice to each of these. So I've got some ice right here, just right from the freezer. This would probably work a little bit better with crushed ice. So if you have that at home and wanted to replicate, you could try and use that. So I'm going to add probably about 5 cubes to each of these, get them pretty full. So now what I've got are 2 metal cans of ice here, and we're going to try and melt this ice that's in here, which is going to do a couple of things as it's happening. One, the ice is going to start to melt into water, and also the cans are going to start to get colder and colder and colder as they're exposed to this ice and this process within. So on the one, we're going to do just water and ice, and on the other, we're going to do salt and ice. So I'm going to label these so when we check back in, we kind of know where they're at. So for the water and ice can, I'm just going to take some regular tap water and I'm going to pour it over this ice. And now effectively what we're going to start to do is, since this water is above freezing temperature and the ice is below, the water and the ice are going to start to share their energy in the form of temperature, and the ice is going to start to melt. It's going to lower the temperature of the water. It's also going to start to melt the ice. In this other can, we're just going to have the ice and we're just going to pour salt over it. So we're just going to get this with lots of regular old table cooking salt. We're just going to kind of sprinkle this all throughout, and this ice and this salt are going to start to react and start to melt as well. All right, so we're going to give these a good 5 or so minutes to start to melt the ice within, and then we'll come back and we'll check them out in just a little bit. So I'll see you soon. All right, and welcome back. So these have been sitting for about 5 minutes or so, and that basically just lets the temperature start to kind of get to an even level within the cans. And because the cans are made of metal, they're excellent conductors of temperature as well. And so inside, that water is getting really cold as it starts to melt the ice, or the ice water that's forming as the salt melts the ice is also getting very cold. And that's pulling energy from the cans. It's making the cans almost as cold as what's going on inside here. And so you can see this is our water and ice. It feels very cold to the touch. And I've kind of taken just some drops of water and kind of just ran them down and along and spread them along our can. And they're staying liquid. So you can kind of see if I push them on here. Still just kind of water droplets. They're very cold, but they're still liquid water. If you look here, the can that had the salt and ice, where I've kind of put some of this water, it's actually frozen into these little ice droplets. I can just put a new drop there. But you can see where it was at. I've put some on here. They've had a chance to actually freeze, so we've got this ice on the side of the can here where this water droplet started to run down, and they've actually frozen solid. Even though we're in a room that is, pretty comfortable, almost room temperature. And so what this is showing is that the salt in the water, that salt water, actually has a freezing point depression. Its freezing point goes from something around 0 degrees Celsius to a couple degrees below that, probably right around -2, give or take, degrees Celsius. So it actually freezes a little bit colder and then sort of melts above that as well. And so what that means then is that this can is actually colder than this can by a couple of degrees, and it's enough that water on the outside of this can is actually freezing into kind of like a frosty or icy layer. And so when we throw salt or similar salt-like products out onto the sidewalks or the roads in the wintertime, that starts to mix with the snow and the slush and the ice, and it actually lowers the freezing point so that in colder temperatures we might actually see it start to melt. So we can sort of melt it away even though the temperatures are colder than what would be the normal freezing point for water. So a little bit of kind of timely, snowy, icy sidewalk STEM for you today. Well, thank you so much for joining us, and I hope to see you next week.